In the beginning, there was an explosion, a cataclysmic burst of energy that birthed the universe as we know it. For decades, the Big Bang Theory has been the cornerstone of our cosmic understanding, a singular event that ignited the stars, galaxies, and everything in between. But what if this explosion wasn't the definitive beginning? What if the universe's birth is shrouded in mysteries we've only just begun to unravel? Recent observations from the James Webb Space Telescope have thrown a wrench into our neatly packaged cosmic narrative. Astronomers are now witnessing fully formed galaxies emerging far earlier than our current models predict, igniting a debate that questions whether the Big Bang was truly the universe's first spark or merely one chapter in a far grander cyclic saga of cosmic evolution. Imagine a universe where time itself is not linear, where the birth of galaxies is part of an eternal cycle of creation and collapse. A universe where what we perceive as the Big Bang is simply one ripple in an endless ocean of cosmic events. Alternative theories like the eternal inflation model suggest that our universe might be just one bubble among countless others, each continuously popping into existence in a vast multiverse. Meanwhile, the cyclic universe hypothesis proposes that the cosmos undergoes endless cycles of expansion and contraction, much like the beating of a cosmic heart, while the ekpyrotic universe theory envisions a dramatic collision between higher dimensional membranes, birthing our universe in a cosmic clash. Today, we dive deep into this ultimate space-time paradox. Join me as we peel back the layers of our cosmic origins, question what really sparked our existence, and explore the mind-blowing possibilities that lie beyond the traditional Big Bang narrative. Strap in. The journey to the edge of time and space begins now. The Big Bang Theory has long been hailed as the ultimate explanation for our universe's birth, a singular, monumental event that set everything into motion. According to this model, nearly 13.8 billion years ago, all of space, time, matter, and energy emerged from an infinitely dense point, exploding outward to create the cosmos. For generations, textbooks and scientific papers have painted a neat picture: a sudden burst of creation, followed by a gradual expansion that formed stars, galaxies, and ultimately, life itself. But recent observations have started to expose unsettling cracks in this seemingly flawless narrative. Imagine looking deep into space and time, peering into the cosmic past with the most advanced eyes we've ever built, the James Webb Space Telescope. Instead of finding a simple linear timeline of events, astronomers are encountering fully formed galaxies that shouldn't exist so soon after what was believed to be the universe's inception. These galaxies appear mature, structured, and brimming with stars, as if they had billions of years of evolution under their belts. How could such cosmic structures emerge in a universe that was supposedly still in its infancy? This discrepancy is more than a minor detail. It challenges the very foundation of our understanding of cosmic evolution. Consider for a moment the awe-inspiring sight of these early galaxies. In our standard model, the early universe should have been a turbulent, chaotic place, a primordial soup slowly cooling down, with matter gradually coalescing into the first stars. Instead, we see evidence of order and complexity, where we expected disorder. This isn't just a gap in our timeline, it's a profound mystery that forces us to ask, what if the Big Bang wasn't the singular, all-encompassing event we've been led to believe it was? One possibility is that the Big Bang is just one moment in a far grander cycle of cosmic events. What if our universe isn't a one-off explosion, but part of an endless series of births and rebirths? Imagine a universe that doesn't simply start and then expand, but one that continually oscillates between periods of creation and destruction, a cosmic heartbeat that never truly stops. In this vision, the Big Bang might be more akin to a phase transition in an eternal cycle rather than a definitive beginning. This idea challenges the traditional view of time as a straight arrow, suggesting instead that time might be cyclical or even multidimensional. Adding fuel to the fire of cosmic controversy is the concept of eternal inflation. In this model, the universe is not a singular entity with a clear beginning and end. It's a vast, bubbling multiverse, with each bubble representing a different universe. Our universe could be just one tiny bubble among an infinite froth of cosmic possibilities. In this scenario, the process that gave rise to the Big Bang is not unique at all. It happens over and over again, creating countless universes with their own distinct laws of physics. The implications of this idea are staggering. Not only does it challenge our notions of origin, but it also forces us to confront the possibility that the story of our own universe might be a small chapter in an infinitely larger cosmic saga. Even more intriguing is the cyclic universe theory. According to this model, the cosmos undergoes endless cycles of expansion and contraction. After a period of expansion reminiscent of the Big Bang, gravity, or some other mysterious force, eventually slows the expansion, halting it and causing the universe to contract in a dramatic Big Crunch. This collapse, however, doesn't signal an absolute end. Instead, it sets the stage for another explosive rebirth, another Big Bang, and the cycle begins anew. Visualize the universe as a gigantic, pulsating organism, rhythmically contracting and expanding, each cycle marking a new phase of cosmic existence. In such a scenario, what we call the Big Bang might simply be a recurring event, a cosmic reset button that has been pressed countless times over an eternity. But perhaps the most radical alternative comes from the realm of string theory, the ekpyrotic universe model. This theory suggests that our universe was born not from a singular explosion, but from the collision of higher dimensional brains, enormous membranes that exist in dimensions beyond our ordinary perception. When these brains collide, they don't simply vanish. They unleash an immense amount of energy, sparking the birth of a new universe. In this view, the Big Bang is not an isolated event, but the consequence of an ongoing process within a much larger, multidimensional framework. It's as if our universe is just one slice of a far more complex and layered reality, where the familiar dimensions of space and time are only part of the story. Returning to our observations with the James Webb Space Telescope, the data presents a tantalizing puzzle. The unexpected maturity of early galaxies suggests that something is accelerating their evolution, something that our current understanding of the Big Bang can't quite account for. Are these anomalies evidence of an underlying mechanism at work? A hidden process that drives cosmic evolution more rapidly than the conventional model predicts? Or do they hint at a radical new theory, one that forces us to rethink the very nature of time and space? In exploring these questions, we step into a realm where science meets philosophy, where the known and the unknown merge in a dance of cosmic intrigue. The cracks in the Big Bang narrative aren't just scientific curiosities. They're doorways into deeper questions about existence itself. What does it truly mean for something to begin? How do we define time when it might not be a straight line but a loop, a spiral, or even a fractal pattern? And if our universe is just one of many, each with its own unique story, what does that say about the nature of reality and our place within it? As we peel back the layers of these mysteries, we must also consider the implications for the future of scientific inquiry. New telescopes and observational tools are pushing the boundaries of what we can see, probing deeper into the fabric of the cosmos than ever before. With each discovery, we're forced to ask more questions, challenging long-held assumptions and opening our minds to a universe that is far more dynamic and mysterious than we ever imagined. The traditional narrative of the Big Bang is no longer sufficient to explain the full scope of cosmic phenomena, and the scientific community is gradually embracing a more nuanced view of our origins. one that may ultimately reveal that the universe is not a static monument to a single event, but a vibrant, evolving tapestry of interwoven cycles and infinite possibilities. In this journey of discovery, we stand on the precipice of a new era in cosmology, one where the universe's most fundamental secrets are coming into sharper focus. The questions we raise today may well be the keys to unlocking the mysteries of tomorrow. And as we continue to push the boundaries of knowledge, we must remain open to the possibility that our understanding of the universe is still in its infancy, a mere glimpse into a much more complex and awe-inspiring reality. Stay tuned as we dive even deeper into these alternative theories, exploring the evidence, the implications, and the mind-bending possibilities that arise when we dare to question the very origin of the cosmos. The cracks in the cosmic narrative are widening, and it's up to us to piece together the fragments of a puzzle that spans not just space, but time itself. As we peel back the layers of the Big Bang narrative, a universe of alternative possibilities emerges, each one as compelling and mysterious as the next. In this chapter, we dive into 3 groundbreaking theories that challenge the conventional wisdom of a singular cosmic birth. These ideas don't just tweak the story, they fundamentally reimagine our universe as a dynamic, ever-evolving tapestry of creation, destruction, and rebirth. Picture the universe not as a singular, expanding entity, but as an unending, frothy sea of existence. The eternal inflation model suggests that our universe is merely one bubble in an infinite multiverse, an endless ocean of ever-expanding realities. Inflation, the rapid expansion of space following the Big Bang, was once thought to be a brief, isolated event. But what if inflation never truly stopped? What if, beyond our cosmic horizon, new universes are constantly forming, each one bursting into existence like a soap bubble in a limitless, roiling sea? Imagine floating in a cosmic abyss, peering into the distance where, instead of stars, entire universes flicker like distant lanterns. Each one is governed by its own rules, its own physics, its own concept of time. Perhaps in one, gravity is repulsive rather than attractive. In another, time flows backward, rewriting existence as if reality were playing in reverse. This theory forces us to confront a deeply unsettling possibility. Our universe is not special. It is merely one of an infinite number, a random byproduct of an ever-replicating cosmic mechanism. But if the multiverse is real, then why did we end up in this particular universe? Why does reality feel tailor-made for us? Could it be that life, consciousness, and even the very structure of reality itself are nothing more than a cosmic accident? The eternal inflation model doesn't just alter our view of the universe, it transforms our understanding of reality itself. Now, imagine a universe that doesn't simply expand forever, but instead breathes, a cosmos caught in an eternal cycle of birth, death, and rebirth. This is the foundation of the cyclic universe theory, a model where the Big Bang is not the beginning, but merely the latest in an endless series of cosmic rebirths. In this vision, the universe expands for billions of years, growing vast and cold. But instead of stretching into oblivion, something profound happens. Gravity, or perhaps an unknown force, reverses the expansion. The cosmos contracts, collapsing back into an ultra-dense state before igniting once again in a new Big Bang. Could remnants of past universes still exist, hidden in the fabric of space-time? Scientists have searched the cosmic microwave background, the faint afterglow of the Big Bang, for signs of previous cycles. Some claim that peculiar temperature anomalies may be ancient scars, whispers of a universe that lived and died before ours. But this idea is not just a scientific model, it is a story as old as time itself. Across cultures, myths of endless cycles abound. The Hindu concept of cosmic rebirth, the Norse tale of Ragnarok and renewal, the ancient belief that history moves in great, repeating epochs. What if the cosmos itself follows the same rhythm? If the universe is locked in an infinite loop, then what does that mean for us? Are we fated to exist in a universe that will be reborn over and over again, each version slightly different from the last? More disturbingly, if the cycle is inevitable, does that mean we have lived this exact moment before? Now, take a step further, beyond even the limits of space and time as we know them. What if our universe wasn't born from an explosion, but from something far more profound? The ekpyrotic model, inspired by string theory, presents a truly alien concept, that our universe was created not by chance, but by a collision, a violent meeting of vast, higher dimensional structures known as brains. Imagine two massive, invisible cosmic sheets drifting in an unfathomable, higher dimensional space. They float silently, like ancient gods, separated by an unseen abyss. For eons, they move in parallel. Then, in an instant, they collide. The energy released is beyond comprehension, enough to ignite a universe. But this was no ordinary explosion. Unlike the traditional Big Bang model, which describes a singular point of creation, this event was physical, an impact so vast it reshaped the very fabric of reality itself. If our universe emerged from such a collision, then what lies beyond it? Could there be other brains, other universes waiting to collide? Is this event cyclical as well, a never-ending dance of creation through destruction? And if dimensions beyond our own played a role in the formation of our universe, then could there be forces, entities, operating beyond our perception? Could there be remnants of this collision still echoing through our cosmos, waiting to be discovered? Each of these theories, the eternal inflation model, the cyclic universe, and the ekpyrotic model, shares one striking implication. The universe may not have had a true beginning at all. Instead of a singular event, reality may be part of an infinite, self-replicating process, a never-ending cycle of creation, destruction, and rebirth. If so, then the biggest question in cosmology shifts from what caused the Big Bang to what came before it. Perhaps the better question is, does before even exist? Modern physics is on the precipice of answering these questions. The James Webb Space Telescope is peering deeper into time than ever before. New theories of quantum gravity are reshaping our understanding of existence itself. And yet, for every answer, new mysteries arise. What if our universe is part of something even greater, something beyond even these alternative theories? Perhaps the truth of the cosmos is even stranger than we can imagine, and if that's the case, then what comes next? Stay with us. The journey into the unknown is only just beginning. Imagine a future where the cosmos unfolds before us like an endless tapestry of mysteries, each thread a clue to the ultimate nature of existence. In this brave new era of science, the idea that the Big Bang was not the absolute beginning of everything forces us to rethink the very foundation of reality. If the universe had a prehistory, if there existed epochs or even entire realms before the cosmic explosion we call the Big Bang, then every notion we hold about time, space, and existence itself could be on the verge of a radical transformation. At the heart of this reimagining is a fundamental question. What if our universe is but one chapter in an ever-evolving story? Instead of a singular moment of creation, we might be witnessing the aftermath of cosmic cycles or collisions that stretch far beyond our current understanding. Picture a universe not as a static, isolated event, but as an endless interplay of birth, evolution, and rebirth, an eternal dance of creation where each cycle gives way to another, and the end of one epoch seamlessly becomes the beginning of the next. In this new paradigm, time ceases to be a linear progression from a defined start to an uncertain finish. Instead, it transforms into a vast, multidimensional canvas where past, present, and future interweave in complex patterns. The conventional arrow of time, the idea that time moves in one immutable direction, could be just one perspective among many. New theoretical frameworks may reveal that what we perceive as time is only a shadow of a far more intricate structure, one where causality itself might be reversible or multifaceted. The implications of this possibility are staggering. Consider the impact on our understanding of the laws of physics. If the universe is cyclic or arises from events that precede the Big Bang, then the fundamental constants and forces that govern reality might not be immutable after all. They could be the emergent properties of a deeper, underlying order that we have only begun to glimpse. This could lead us to a unified theory that not only marries quantum mechanics and general relativity, but also uncovers the hidden symmetries of nature. Such a breakthrough would not only rewrite textbooks, it could redefine what it means to exist. This vision is propelled by advancements in technology that allow us to peer deeper into the cosmos than ever before. Telescopes like the Nancy Grace Roman Space Telescope are poised to revolutionize our view of the universe. With its unprecedented sensitivity and clarity, this new generation of observatories will act as time machines, enabling us to see back to epochs that were previously shrouded in mystery. Imagine capturing the faint glow of light from the earliest moments of a cosmic cycle, a glimpse into an era before the Big Bang as we know it. These observations could reveal patterns in the cosmic microwave background or other relic radiations that hint at pre-Big Bang conditions, offering tangible evidence of the processes that set the stage for our universe. The discovery of such evidence would be a turning point for science. It would validate theories that, until now, have existed primarily on paper. Complex mathematical models that propose dimensions beyond the familiar three of space and one of time. By testing these models against observational data, scientists could unlock the secrets of higher dimensions, providing insights that might explain the behavior of gravity, the nature of dark matter, and even the mechanisms behind cosmic inflation. This quest is not merely academic. It strikes at the core of our human desire to understand our place in the cosmos. Moreover, the philosophical ramifications of these discoveries are profound. Throughout history, creation myths and religious narratives have offered explanations for the origin of the universe. If science begins to support the idea that the universe emerged from a prior state of cosmic activity, be it through collisions of multidimensional brains or through the ebb and flow of cosmic cycles, then the boundary between science and mythology may blur. This convergence could foster a new era of interdisciplinary dialogue, where the insights of physics, philosophy, and even art coalesce into a richer, more nuanced understanding of existence. Imagine the cultural impact of such a paradigm shift. Literature, art, and music have long drawn inspiration from the mysteries of the universe. The realization that our cosmos is part of an eternal cycle where beginnings and endings are intertwined could ignite a renaissance of creative expression. Artists and thinkers might explore themes of rebirth, transformation, and the infinite, crafting works that capture the awe-inspiring beauty of a universe in perpetual flux. In this way, the future of science is not only about technological progress and empirical discovery. It is also about deepening our collective narrative and enriching the human experience. In conclusion, the possibility that the Big Bang was not the definitive beginning, but rather a moment in an ongoing cosmic saga, challenges us to expand our horizons. It it beckons us to question the very nature of time, space, and existence, and to embrace a universe that is far more intricate and interconnected than we ever imagined. As new telescopes and theoretical breakthroughs push the frontiers of our knowledge, we stand on the threshold of discoveries that could redefine the fabric of reality. This is not merely a scientific revolution. It is a call to reimagine our place in the cosmos, to see ourselves as part of an endless dance of creation that spans the infinite tapestry of existence. Our exploration into the origins of the cosmos leaves us with more questions than answers, a call to keep exploring. Today, we ventured beyond the familiar Big Bang narrative into a realm of bold alternatives. From the endless universes of eternal inflation, through the rhythmic cycles of the cyclic universe, to the dramatic collisions of the ekpyrotic model, each theory invites us to reimagine our cosmic origins and challenges our understanding of space and time. This isn't just scientific debate, it's a journey of wonder and discovery. Every new observation opens up fresh mysteries, urging us to look deeper and question what we think we know about the universe. Thank you for joining me on this mind-expanding journey. If these ideas sparked your curiosity, please like, comment, and subscribe for more explorations into the unknown. Remember, the universe is full of secrets waiting to be discovered, and our quest for truth is just beginning.